Okay, BC, as promised, I want to make sure that I just show you a very short 5-minute lesson on just simplifying factorials. So this example we did in class today, I had you using the ratio test, I think, looking at the ratio of the n plus first term over the nth term to determine whether this sequence here is decreasing, increasing, strictly decreasing, strictly, et cetera, okay? And notice here that when I did a sub n plus 1 divided by a sub n, I took the liberty to multiply by the reciprocal, okay? And many of you probably got to here, 10 to the n plus 1 over 10 to the n, using properties of exponents, that does in fact simplify to 10. Now, the task becomes simplifying this expression, a quotient of factorial expressions. I'm going to go over here and do a little kind of a shortcut here. As I said to you in class, 8 factorial, right? It is not equal an excited 8. 8 factorial is 8 times 7 times 6 times 5 times 4, okay, all the way down to 1, right? So this is not 8 happy 8 or excited 8, because that would be an absurd idea. So 8 factorial is here. You're going to have situations where you have something like this, like 28 factorial divided by 25 factorial. And what we're going to use here is the idea of common factors. 28 factorial is nothing other than 28 times 27 times 26 times 25 factorial, all divided by 25 factorial. Correct? And notice that if you write 28 factorial this way, you're able then to cancel out common factors. Similarly, if I had something like this, n plus 3 factorial all over n plus 1 factorial, well, let's think about it. N plus 3 factorial is going to be the product of all the integers from n plus 3, reducing by 1 each time, all the way down to 1. So if I were to expand n plus 3 factorial, I would have n plus 3 as the first integer, times n plus 2, times n plus 1, and this continues going on down, right? But I'm just going to do this. To describe this continual behavior, I'm going to do that, n plus 1 factorial. And you notice over here, that is over n plus 1 factorial. And in fact, you'll see that these are able to be canceled out. So back to the question over here. We're left at this point with 10 times the quantity 2n factorial all over the quantity 2n plus 2 factorial. And because n is a positive integer, it is very obvious upon inspection that this number, 2n plus 2, is bigger than 2n. So all I'm going to do is write 2n plus 2 factorial as an expanded expression. Okay, so once again, the first term is 2n plus 2, then times the next integer, it's 2n plus 1, and then the next integer down is going to be 2n, and then that, of course, keeps going on down. But I'm going to describe the rest of those factors just as the quantity 2n factorial, and then I'm able to do this and this. So at the end of the day, when I'm here, I have 10 all over the quantity 2n plus 2 over 2n plus 1. And it's very clear to me that for values of n that are pertinent in this work with sequences, this expression here will always be a positive number or bigger than 0. Therefore, I have just shown that a sub n is strictly increasing. Okay, very good. So I posted the homework on the teacher page. Please do that, and I will see you on Tuesday. Please note that on Tuesday you have 2 things due, homework and a take-home. Thank you and good night.